Homework problem 7A. What mass, so there's our question, of calcium carbonate must decompose to produce 250 centimeters cubed of carbon dioxide at STP? Calcium oxide is your other product. So we do have a stoichiometry problem. Let's go ahead and write down what we know. So calcium carbonate decomposing into carbon dioxide and calcium oxide. Okay. So it wants to know what mass. So mass is grams. Carbon dioxide says we have 250 centimeters cubed. And it doesn't say anything about the calcium oxide. Okay. But it does say we're at STP, which is 273 Kelvin and 1 atmosphere of pressure. So let me ask you this. Is this a stoichiometry problem? Yes, it actually is a stoichiometry problem. Is this a limiting reactant problem? No, it is not. Why? Because there's only one reactant. Also, we're looking for something about the reactant. So this is not a limiting reactant problem, but it does have a gas in it, which is carbon dioxide. So that's why we care about STP, but it is a good old stoichiometry problem. So step one, write a balanced equation. It's pretty darn good. 1 calcium, 1 carbon, 3 oxygen, 3 oxygen. So it's balanced. Step two, take what was given. So we have 250 centimeters cubed of a gas, carbon dioxide, and let's convert that into moles. So that means that we need to convert centimeters cubed into milliliters, milliliters, into liters, liters, into moles at STP. Okay. So 1 centimeter cubed, again, equals 1 milliliter. There are 1,000 milliliters in a liter, so 10 to the 3. And, and we'll use STP, so 22.4 liters equals 1 mole of carbon dioxide gas. So again, pretty extensive step 2. Okay, so pretty extensive there. But once we get that, then it just rolls by pretty quickly. So now we have our moles of carbon dioxide, so let's do our mole ratio. And what are we looking for? Calcium carbonate. So our numbers are 1 and 1, pretty nice. And then it wants us to find the grams or the mass, so go one more step. Convert the moles of calcium carbonate into grams of calcium carbonate. And I know that's around 100. I want to say it's 100.089. Yeah, let's get it. 100.09. Yep, it's close. Okay, so we have our step 3 and our final step 4. So whatever that equals. Okay, so let's get a number there. And that equals 1.12. And that is grams of calcium carbonate. Okay. All right, let's take a look at 7C. How many liters of phosphorus pentachloride, so it's looking for a volume, are formed when 7 liters of phosphorus trichloride react with 9 liters of chlorine gas? So it kind of told us how much of something is being formed. So PCl5, and wants to know how many liters. So question mark, volume. When it says that we have 7 liters, as phosphorus trichloride. 7 liters? 7 liters. And we also have 9 liters of chlorine. Okay. Alright, so it is a limiting reactant problem. Step 1, balanced, good. So it doesn't matter which one you pick. Hopefully you could look at this by now after doing quite a few limiting reactant problems and get a pretty good idea who the limiting reactant is, since it's 1 and 1 here. Okay, so I'm going to just, for hypothetical sake, say 9 for our limiting reactant step. Okay, but I know that you're smarter than that. You would have chosen the other one, or you actually know that the other one is the limiting reactant. Okay, so, and if you don't, then that's okay. We'll get you there. And then use your mole ratio. So 1 mole of chlorine to 1 mole of PCl3. Okay, and then we want to go back. So 1 mole is equal to 22.4 liters. Okay, so again, the 22.4 liters can cancel. Everything else is 1, so that means that we would have 9 liters of PCl3. So when answering this question, if I were to use all of my chlorine, I would need 9 liters of PCl3. I only have 7, my limiting reactant. Is that okay? Okay, so now I know who my limiting reactant is, I can answer the question. So we have 7 liters of PCl3. And do your magic. Okay, so again, no calculator required here. 7 times 1 divided by 1 equals 7 liters of PCl5. Probably one of the easier questions that you could ever see.